Wireless systems are everywhere. Drones, vehicles, wearables, and other devices all talk at once on the air. Operators need to find the right signals, understand what they mean, and act in real time. Many tools can help, but they are expensive, specialized, and hard to scale across lots of small edge nodes. The Department of Defense needs a common, low-cost framework that runs on off-the-shelf hardware. FISSURE is that framework. It is open source. It runs on software-defined radios with a plug-in architecture, and it presents a simple Python dashboard built with PyQt5. Under the hood, it uses GNU radio flow graphs, so new radios, detectors, and actions drop in without touching core code. Our detection and classification follow established radio practices. When we evaluate, we look at alert quality, accuracy, and the operator's workload. A central hub coordinates remote nodes over 0MQ on Internet Protocol networks. Meshtastic carries small commands and alerts when links are limited or long range. When bandwidth is tight, FISSURE sends compact status and alert messages now and holds larger files to sync later, so useful queues keep moving even on intermittent links. FISSURE can also queue cameras and microphones. It integrates with the Team Awareness Kit, or TAK, to place alerts on a shared operational picture. Most actions today are operator-driven. Simple tasks already run on their own, and broader hub-level automation is in active development. This is edge computing in practice. FISSURE runs on small devices at the edge. In one use case, a perimeter drone carries a FISSURE node. The operator loads a survey preset. An unusual signal appears. FISSURE classifies it and posts a TAK alert with a location and a confidence estimate. The hub then tasks a nearby ground node to listen from another direction. With 2 points listening, the estimate tightens and the map pin updates. With one tap, the drone shifts from survey to collect. It saves short IQ clips, sends small detection messages, and cues the camera to record brief video while it loiters. As the drone reaches a stronger network link, the larger files begin to sync in flight. If policy allows, the operator can request a localized, approved effect. If not, collection continues and the thread is handed off with evidence in context. For a single operator, FISSURE shortens the path from detection to decision. Find the signal, validate it, capture radio and visual evidence, publish to TAK, then act or hand off. That saves time, reduces the number of people tied up, and lowers risk at the edge. For units, a shared open framework scales to many low-cost nodes and turns good tactics into reusable pieces that work in the air, on the ground, and at sea. Across the department, FISSURE helps avoid vendor lock-in, lowers sustainment costs, and speeds the way new sensors and effects reach the field. Day-to-day, the goal is fewer handoffs, faster movement from the first indication to a confident decision, and lighter kit to carry. We track time to first alert, alert quality, behavior on weak links, and operator workload, and we report results through pilots. Single-device radio apps are built for one radio in one pair of hands, which makes multi-node tasking hard. Large proprietary suites can be powerful, but they are costly to extend and can lock teams to a vendor roadmap. Generic ML toolkits are built for files, not live radio, and they often lack short capture windows, replay, constrained link handling, or TAK-aligned workflows. FISSURE closes those gaps. It uses an open plugin framework and hub coordination to bring listening, collection, analysis, and effects into one operator workflow. The operator stays in the loop, and actions follow policy. The core framework is open source. Revenue comes from engineering services and from training and support. Private plugins are available when needed. Partner hardware bundles and enclosures keep adoption costs low, while funding mission-specific capability and sustainment. This open core plus services model lets teams start with pilots and training before they commit to more. FISSURE is available now. Install it on a compatible computer and radio. Try a short scenario. Then contact Assured Information Security to begin a pilot and turn detection into decisions at the edge.